Hey, Business 20 students, this is Mr. Doucette, and this is chapter 11 on compound interest. We just got finished looking at simple interest, and simple interest is really just interest over a period of time. Usually annually, you get compounded annually, really, and every year that you get a little bit more interest on your money. Where compound interest is quite different. It's called the magic because you're basically not only getting interest on the original principal that you invested or that you borrowed, it's also interest upon the interest. And that's where it becomes very powerful. For instance, look at this chart with me here. Right here, it has some dollars. And basically, this is based on somebody investing $1,000 at 10% interest for 30 years. They put $1,000 in at 10% a year and they let it sit there. And over the course of 30 years, that $1,000 became $4,000. So basically, every year, they just get another 10% on their $1,000 until the very end of 30 years. They have 4,000. So they've quadrupled their 1,000 in that scenario. However, if you look to the right of that, this person here did the same thing, invested $1,000. However, that was compounded. And what I mean by that is it's interest upon the interest. So originally, the first loan, they put 1,000 in, and then they made a little bit of interest, but that interest wasn't added back to their principal. It was just another year went by, they got another same amount. Another year went by, they got the same amount. Another year went by, they got the same amount because it was still based on the $1,000. In compound interest, what we do is we take the principal amount and then we add the interest that was earned, and now that becomes the new principal. So every time it's compounded and interest is earned, the interest is added to the principal. And so therefore, every time interest is taken, a little bit more is taken, a little bit more of, is given, a little bit more of a percentage is given. And pretty soon it snowballs and you really see a significant difference. Notice here in our example, the first year they put in 1,000 at the same as the first example. By the end of year one, they both had $1,100 in them. However, because they took that 100 and they added it to the principal, the next year, the interest was compounded on not 1,000, but on 1,100. And the interest was taken. So there was going to be a little bit more interest earned as a result. And as that keeps happening, every time the interest is earned, it's added to the principal. Now you're getting interest the next time on your principal and your interest. And the more that principal grows because you're adding interest to it, the higher your interest amount's going to be each and every time. So you can see the example it goes from year 1 to year 5 at almost $1,600. At year 10, it's almost $2,500. It's actually a little bit over $2,500. And then at year 20, it's almost $6,700, almost $7,000. And by year 30, it's almost $17,500. Same $1,000 in the bank, but one's compounded and one wasn't. So the 17,000 obviously shows you the power of compound interest. The same example is given to the right there. This is 3 people that invest $5,000 a year towards their retirement. Susan invests $5,000. That's the first example. She does it for the 10 years between the ages of 25 and 35, and she just invests $5,000 a year and then she stops. So her total investment was $50,000 over 10 years. If she just stops right there, doesn't add any more money to her account or her savings, and just lets it compound, by the end of 30 more years, when she's 65, she'll have $602 in her account. That 50,000 grew to 605,000 over the next 30 years, all because of compound interest. That's pretty good. Now compare her to Bill, who starts when he's 35, and he actually invests 5,000 every year all the way until he's 65. And because he started late, the compound effect didn't have a chance to go as significantly as you might want. And over those 30 years, he actually contributed $150,000 towards his retirement. And when he retires, he will have, I think this is based on 8%, he would have $540,000 in his retirement savings. So it would have been better to put in money between 25 and 35 and let it compound versus 35 all the way till he's 65, and he's going to have less as a result. But the best scenario, of course, is Chris. He starts when he's 25 and he invests 5,000 all the way until he is 65. So he invests $200,000. However, By the time he retires, he's going to have 1.142 million. So he is going to be a millionaire in his retirement because he put in that 5,000 every year for the 40 years and it compounded. And as a result, he obviously is going to have almost double the retirement amount of money as the person before him who started, who only did the first 10 years. And he's going to have certainly more than double of the person who started when they were 35. So this just shows you the value of compound, and time is your friend because the more time you have, the more it compounds and the more money you ultimately make. So that's what we're talking about in this chapter is compound interest and how do we calculate it. And of course, down the bottom here, we have our formula, compound interest, because a lot of the questions they ask you, what is the compound interest? Well, it's pretty simple. It's the full compounded amount, or what we also call the future value. That's including the principal and all the interest. That future value minus the original principal that you invested. So this is the principal you invested. This is the total value of that at the end of the term. So future value minus the principal equals the compound amount, or you might say the compound interest. How much interest did you earn? And that's what we're going to be calculating in this chapter. So I'm going to move now to our first problem. Now, the first problem we're going to solve actually comes from section 11.1, and this is calculating compound interest or compound amount based off using the manual method of doing so. And this is kind of the longhand way of doing it, and we're only going to show you this to show you how compounding works. And then we're going to get into doing the compound amount based off of tables, which is really the easiest way to do it. But I'll show you that. So we're going to start with this problem here. All right, here we're going to work out manually calculating compound interest. We're going to be looking at this problem. Katie Trotta, $20,000 in a passbook savings account that gives her 5% interest compounded annually for 2 years, meaning that every year that interest is earned, it is then added to her principal. And then the next year, she's going to get interest upon not only her principal, but the interest as well. So we'll look at that together. She has $20,000. Sorry about that. Let's erase that. $20,000 times the interest rate, 0.5, equals at the end of the first year. This is right in your book, by the way. I'm just working out just like the book did. At the end of the first year, she had $1,000 interest. You're going to add that to her principal, 21,000. That's year one times 0.05 equals 1,000. What is it? 1,050 for year two. You're going to add that. So now she has $22,050. So at the end of year two, that is her compound amount. You might say, well, how much interest did she earn? That's what we want to find out. So 22,050 minus 20,000 was $2,050 interest, or yeah, that's what we call the compounded interest. That's how much she earned in those 2 years. All right, we're going to do the same problem. This time we're going to manually calculate the compound amount from the previous example. We're going to use semi-annual compounding this time. So before we were just doing it by the year. Now we're going to do it by twice a year. So in this case, we're going to somewhat use our simple interest formula, 0.05 times 1/2. Remember, you could do 6. We could do 6 by 12, but 6 by 12 is the same thing as 1/2. So we're going to just do it by 1/2. So we're going to do the same thing we did when we were doing simple interest, $20,000 times 0.05 times 1 divided by 2 equals. So the first 6 months, she got $500. No surprise. That's pretty much the same thing she got before. However, now we have $20,500. And this is going to be year 1A, and this one will be year 1B. So 0.05 times 1/2 equals. So how much she made now? 20,500 times 0.05 times 1 divided by 2 equals. So now she made $512.50. So our compounded amount for starting year 2 is $21,012.50. And we're going to multiply that by 0.5 times 1/2. That'll be for the 6-month point of year 2, first 6 months. So 21,012.50 times 0.05 times 1 divided by 2 equals. So now she made $525.31. We're going to add that to the 21,012. Oops, sorry. So that comes out to 21,537.81 when I added the 525.31 of interest she earned in year 2A. And now we need to figure out year 2B to find out what the total compound amount was. So we're going to multiply that amount by 5 times 1/2 equals times 0.05 times 1 divided by 2 equals another $538.45. And we're going to add that to the 21,537.81 plus 538.45. And that total comes out to $22,076.26. So that is my compounded amount at the end of those 2 years. Now, how much compound interest did they earn? Again, 20,000 was my original investment minus 22,076.26. They made $2,076.26. Now, notice it doesn't seem like a lot, but compared to just doing the compounding once a year and to doing it twice a year, she made an additional $26.26. So it just goes to show the more you compound, the more you will make, because it's adding, you're starting with a higher principal every time you compound. And as a result, you end up making more interest. So that's doing it manually. And you may have a couple of problems going over that. You might say, well, what's the purpose of this? Because you want to see how much money you're going to be making. You want to see how much that $5,000 that you're investing today is going to be worth in 10 years if you use compound interest. You want to make sure that you're making money off of your money. And so it allows you to plan, it allows you to prepare for what purchases you might have, or even just that money that you're going to need when you retire. So we'll move on to the next problem. All right, this is our next problem. And actually, it's another one of the same kind where we're manually calculating compound interest. And I felt like, I guess I felt like we really didn't cover it in that last question. So I'm going to go ahead and do this one here as well. This one is going to be Gail Parker. She's going to invest $10,000 at 6% interest for 3 years. And she's going to compound it semi-annually. So there's going to be 6 calculations here. So again, because it's 3 years semi-annual, it's going to be pretty much the same thing we just did. So we're going to take the 10,000, multiply it by the 6%, which is the decimal form of 0.06. And we're going to do the math on that. All right, I just worked it all out and I paused my camera. I just wanted to, rather than have you work with me through the math, it would have taken a long time. I just decided to do it all and then come back. So basically you can see here, year 1 was here. I did it. I multiplied the 10,000 invested by 6%. At 1.5 years, or one half year, came to $300 for the first compound period. And then I added that $300 to the 10. So then I compounded the second time with 10,300 at 6% for a half a year. And that came out to $309. So I added that to the 10,300, and that gave me 10,609. I multiplied that by the 6% and the 1/2 year, and it came out to 318.27. So I added that to the 10,609. It came out to 10,927.27. I ran the interest on that. It came out to another $327.82. So I added that. That gave me 11,255. I ran the interest on that. That was year 3, the first 6 months. And that gave me 337.65. I added that to the 11,255.09. I ran the interest one last time. And the time period, it gave me another $347 worth of interest, that second part of year 3. I added that to the original amount, and that gave me $11,940. That's how much I earned in interest, or that's my compound amount, sorry, or what we also call future value. The future value of $10,000 at 6% for 3 years, compounded semi-annually, is $11,940. How much interest did I earn? $1,940. You might say, well, that's less than the last problem we looked at. Yeah, well, the difference was this was only 6% interest, right? The last one I think was 10%. No, it was 5%. Was it less than the last one? No, it wasn't. It was more than the last one. The last one was only actually the last one was $2,076, but we started with 20,000 at 5%, not 10,000 at 6%. So that's why there's a big difference in the total, but it's because we started with more money that we invested. But either way, it's compounding. Each time that you do it, you compound it on the new principal or the new balance, and then you compound it again, add the interest to the balance, compound it again, add the interest to the balance, and that's compound interest. And that's how it works manually. Now we're going to show you how to do it using the chart. All right, students, as we move in now to section 11.2, we're going to learn how to calculate compound interest using a table. And when you do this, you have to first figure out how many times is a particular amount going to be compounded, and then, of course, what the interest rate is. And you have to keep in mind, everything is always done in years. So your interest rate, when it gives you a stated interest rate, that means over the year. And the same thing is true with the number of times that you compounded. So, of course, 1 year of compounding is one. If you do 2 times a year, that's once every 6 months. That's 2 times you compound it. If you do it quarterly, that's every 3 months. So that's 4 times a year that you compound it. And then, of course, you could even go monthly, which is 12 times that you compound it, or it can be daily, which we already looked at was either ordinary or exact interest. And that's pretty much 365 days that it can be compounded. Now, usually when it comes to compound interest, we use the exact interest because we're doing it every single day. It's compounding again. You're earning interest every day on whatever your principal is, and that interest every day is added to your principal. And then the next day you take interest on what the existing principal was plus the new interest added, and then you get more interest, and it just multiplies and grows. And that's kind of how it works. Well, the table that we're going to be looking at actually just gives you a table factor that you can multiply your principal by, and it'll give you the full complete compound amount at the end of the terms and with the interest rates that you choose. So let me show you the chart. I have to go out into my emails here, and I have to open that chart. So give me just a second. It's right here, and that's chart 11.2. Here's chart 11.1. I'm going to go ahead and open it. And this is the compound interest chart. Now, 11.1 is what we call the future value chart. And this is looking at, if you take a dollar value, you multiply it by the table factor, it will give you the compound amount. And so if you look to the left, there are periods there. That's the number of times that you will compound it over a year. And then across the top are the interest rates. And the top chart goes to 8%. If you go down to the middle of the page, it starts at 9% and goes all the way to 18%. And what this is based off of is $1 compounded. So if you look at, for instance, period number 25, and then you go all the way across to, I don't think I can write it. Yeah, you can. All the way across to 8%, we have a 6.84848, which means that $1 at 25 periods of compounded within a year at 8% interest is going to give you a $6.85 return. And what we do with this table factor is we simply multiply, as I mentioned, your principal by whatever the table factor is, depending on how many times you're going to compound in a year and what the interest rate is going to be. And that's going to give you your ultimate compounded amount automatically. So it's really nice because you don't have to go through all the steps. It just does it for you. So I'm going to go ahead and go back to our worksheet that we were working on. So I got to go back. And let's see, screens for math. Here we go. We're on this one right here. So I have to share that. And I'm going to go back into Easy Teach. So that's what we're looking at here. So let me give you an example of it. Here we're looking, I'll start with this problem right here. And again, compounding interest rate equals the nominal rate plus the periods of the year that you're going to do it. So that's where I'm going to find from the table. I'm going to find the nominal rate, which is the interest rate, and how many times a year it's going to be compounded. So let's look at this first problem, and I think it'll make more sense. John Anderson invests $1,200 in an account for 8 years, at 8% interest. So 0.08 is the decimal equivalent quarterly. That's very important for 5 years. Okay. So what is five? If it's going to be over a 5-year term and you do it quarterly, how many times a year is that going to be? It's going to be 4 times a year, right? So 4 times 5 equals 20. So there's going to be 20 compound periods for the sake of this particular problem. And this is $1,200 at 8% for quarterly for 5 years. So there's going to be 20 periods in which it's compounded. And now when we have an interest rate, just so you know, an interest rate is also annual. So in order to know what interest rate you're going to use every time you compound, you have to also divide that by the same number. So in this case, because it's 8% and it's quarterly, it needs to be divided by 4. So that means that 8% is going to be spread out. So it's going to be 2% at the first time, another 2% at the second time, another 2% at the third time, and then another 2% at the end. So it's going to be 2%, 0.02, and it's going to be 20 periods. So that's where we would go to our chart in order to find that information. So we'll do that real quick. We'll go to our chart. I'll back up here. Sorry, I wish I had a faster way to do this, but I'm going to go ahead and go to chart 102, or 11-1. I'm going to go to 20 periods, which is right here. And you should see that. And then I'm going to go to 2%. So that's right here, right? So my table factor is going to be where those two coincide. So it's 14895. I'm just going to write this down. 1.48595. That's the table factor that we would use. So I'm going to go back to our problem. Apologies, I should have just hit done there. And then I'm going to go back to my screens for math. I probably lost everything I just did, but that's okay. I'll just do it again. So it's this one right here. All right, so again, we had 1,200. So we already figured it was 20 periods at 2% because we were doing it quarterly. So we took the $1,200 and we just multiplied it by that table factor, 1.48595. So if I do the math, I'm using just a simple calculator. It doesn't have to be a scientific one. All the problems in this class should be able to be solved with just a regular calculator. I'm going to multiply that by 1.48595, and that would equal $1,783.14. That is my total compound amount. That's how much my $1,200 will be worth at 8% interest compounded quarterly for 5 years. I'll make it'll now be $1,783. So if I was to deduct 83.14 and I minus the $1,200 off of that, that means I made $583.14 in interest. And so that's using the table factor. So I'll solve a few more of those here in just a second. And that one there was actually example 2 from your book. At the bottom of the page, same part of your book, 11-2. This one says Jenny Choa invested $20,000. So we'll go ahead and write this out. At 6% interest, compounded semi-annually. That means 2 times a year, right? So semi-annually for 8 years. So if I'm going to compound it twice a year for 8 years, how many times am I going to compound it? 16 times. So I'm going to multiply 8 by 2 equals 16. So there's going to be 16 compounding periods. And I got to do the same thing. If I'm going to be compounding 6% over the year twice, I need to divide it by 2. So that's going to be 3%. So I need to go to my chart. I need to find 3% at 16 periods. So I'm going to look on my chart because I don't want to go away from it again here, but I'm going to look up 16 periods and I'm going to go 2%, or no, 3%. and it's going to be 1.60471. That's the table factor. So, by the way, some of the problems might ask you for table factor, so you just need to find that. So in this case, I'm going to take my $20,000. I'm going to multiply that by 1.60471, and it's going to equal $94.20. Again, that is my compound amount. That's how much I will have after 8 years at 6% interest investing $20,000. So I made, if I take the 20,000 and I subtract that from the $32,094.20, I'm basically going to have $2,094 in interest. That's how much interest I earned over the course of that particular loan. So again, I just use the table factor, and that's the easiest way to solve these problems. All right, so I erased all that because I couldn't see the next two problems, which is right here. So we have a couple more here. We have one 5 years. I'm sorry, it's 4% interest, and it's compounded quarterly. And then we have one that is 12 years. That is 8% interest semi-annually. And so it's not difficult to find. Again, we would take 5 years quarterly. So 5 times 4 equals 20. We already kind of did that before. It's 4%. 4% divided by 4, because it's going to be 4 times a year. So that comes out to 1%. So if we just go to find the table factor, we'll look up that one in a second. The other one's 12 years semi-annually. So 12 years twice a year. So it's going to be, it's going to be times 2. Start it over. So 12 times 2 equals 24. So 24 periods. And then I'm going to take the 8%, and I'm going to divide that by 2, and that's going to come out to 4%. So again, when I go to my chart for the first problem, I'm going to go look at 1%, 20 periods, and then the second one, I'll look at 24 periods at 4%. So I'm going to do that right here in my book, because again, I can't, if I navigate away, I'll lose my math here. So if I look it up on the chart in my book, 11.1, same chart I was showing you on the screen, if I take 20 periods and I go 1%, the number is going to be 1.22019. And then if the other one, if I go for 24 periods and I go at 4%, and I look on the chart where those two meet, is 2.56330. And again, all I would need to do is multiply my principal. If I had to, there was no principal given in these problems. They were by themselves. So all they're asking for is what the table factor is. So the first one is 1.22019. The second one's 2.56330. So those kinds of problems. Now, you might say, again, why am I doing this? Because this is a much quicker way to calculate compound interest. If you know the terms and you know how often it's going to be compounded, you can take those terms, you can go to the chart and get your table factor. You can multiply your principal by the table factor, and it will give you the ultimate compound amount at the end of that period. So the end of that loan. So that's a great way to figure it. All right, now sometimes, this is actually section 11.3, and this is calculating the compound amount off of the table when you don't, when the periods that you come up with in the problem are actually larger than the particular chart. So for instance, when I showed you the chart earlier, it only went up to 25 periods. And that's fine, but what happens if your periods end up being like 50, or what if they end up being 40, etc. So there's an extra step that you'll need to take in order to figure out the table factor when that happens. And it's not difficult at all to figure out, but let me give you an example. And I'm gonna write on here, switch away to the table, and then I'm gonna come back and I'll do it again. But basically it says create a new table factor and find the compound amount for $10,000 invested at 6% for 3 years. Now notice this one is going to be compounded monthly, right? Monthly. So if I take 3 times 12, how many periods is that? Because remember, monthly, so it's going to be done 12 times a year times 3 years. So it's going to be compounded 36 times. And it's going to be at 8%. So I would have to divide 8 by 12 as well. So 8 divided by 12 comes out to, oh, excuse me. Hold on. Actually, I made a mistake. It's not 8%, it's 6%. I just didn't write it good. 6%. That comes out to a 0.5%. So it's a 0.5% compounded 36 times. So we're going to go to the table and look that up. And so give me a second. I'll pull up the table. All right, so you should be seeing the table. So we said it was 36 times at 0.5%. However, if you notice, we only have 25 periods. That's the most on our chart. And we have 0.5% right here. So how do we do that? Well, it's pretty simple. We would just take the 36 and divide it by 2. So I'll just write that down. I'll do 36 divided by 2. So basically 36 divided by 2 equals 18. So if I just take the 18 and I take the number from there, the 1.09393. That's the table for 18 at 0.5%. All right, I'm going to go back to my problem. So give me a second to do that. Give me a second here. Hold on. All right. So I'm going to go, oops, sorry, wrong one. This is a different one. It's compound 5. All right, here we go. Sorry to carry you along on this journey. All right, so we said it was 36 times that it was going to be compounded at 0.5%. And we said the factor on the table was 1.09393. That was only for 18. So all you need to do is, since that was 18, you just multiply it again by itself. And then that becomes your new table factor. So in this case, I would simply take the 1.09393 and I would times it by 1.09393 equals. So my new table factor is 1.19662. At some point, you have to cut it off. And I would multiply. It's ideal that you don't, and that's probably why it doesn't come out the same when you're on your formula. So if I just wrote the whole thing out, and then I multiplied my principal, 10,000, by that new table factor. So I'm going to multiply 10,000 equals, comes out to the answer equals 11,966 and 83. So that is my total compound amount. And if you want to figure out how much did I pay in interest, would be, of course, $1,966.83. So that's how much interest. This is the compound amount, and this is the interest. So I just created a new table factor by multiplying the two together that were the same. In this case, the 18 and 18 was 36. So I just multiplied the factor for 18 and 1.5%, and again 18 and 1.5%, multiplied them together, and I got a new table factor. And that's all you need to do on those problems. So again, here's another one. This one's compounded quarterly for 7 years. So 7 times 4 equals 28, and it's $3,500 at 8%. And so we're going to also divide that by 4, so that comes out to 2%. So I'm looking for 2%. 28 periods of compounding. I'll go ahead and look on my chart, and I'll realize right away that there's not 28. So of course, the easy part there is to just divide the 28 by 2. So that would be 14. Take my 14 and go to 2%. And on the chart here, it is 1.31948. I would just multiply that by itself again. That's for the first 14. That's for the second 14. That gives me my 28. So if I multiply those two together, 1.31948 times 1.31948 equals, a new table factor of 1.74102747. And if I multiply that by the $3,500 I started with, my principal, it's going to come out to $6,093.60. And again, I could subtract the 3,500 from that and I would know what my interest is, but this is my compound amount. So in other words, after 7 years at 8% interest compounded quarterly, $3,500 will be worth $6,093. Hey, Business 20 students, this is Mr. Doucette, and I ended my last video working out compound interest using the tables a little abruptly. I had some technical problems, so I had to end it. And I did try and work out this problem down here, but I realized as I was doing so that the interest rate, when I divide it by how many times it's going to be compounded over the course of a year, of course, I had to divide the interest rate by that same amount. In this case, it was going to be compounded monthly, so I needed to divide the 4.5% by 12. And it came out to like 0.75%. And then when I went to the chart, I realized there is no 0.75% on that particular chart or that table. And so this particular problem needs to be worked out using the compound interest formula. And that formula is in your formula sheet, although I don't have it here on this sheet, but it basically is A equals, and A stands for compound amount. So that's what you're looking for. And it equals principal times 1 divided by the interest by the number of terms in which you are going to be compounding it. And so I'm going to give you a sample problem, and then I'm going to go ahead and work out this one down here. The sample problem I don't have, but I'm going to write the details down. It's basically that we're going to compound an investment of $5,000 at 10% interest semi-annually for 3 years. So when we were going to do the table factor, we, of course, we're basing that on how many times is it going to be compounded. So if it's going to be compounded semi-annually, that's twice a year, and we're going to be doing it for 3 years, how often is it going to be compounded? The answer is we're going to multiply 3 by 2, and that comes out to 6. So 6 times it's going to be compounded. And then, of course, our percentage rate is also annual. So if it's 10% for the year, we're going to compound it twice a year. It's going to be half of that. So we're going to divide that by 2, and that's going to be 0.05. And that's going to be, or 5%. That's going to be what we're going to calculate it by. So using our formula up here, I'm going to go ahead and write it down here to make it easy. A equals 5,000 multiplied by 1 divided by the interest rate. So that's 0.05. And then it's going to be multiplied by 6 because there's 6 periods. So that's how we would use the formula. If I am to write it again, just to kind of get the math here, and I finish this first amount of math right here, it's going to come out to 1.05 divided by, or multiplied by 6, right? And then if I write it again, 5,000, it's going to be multiplied by, I'm just going to go ahead and write the whole amount, 1.34000956. That's what this 1.05 to the 6th power comes out to. And then that's going to give me, if I do the math there, A equals 6,700.4782. And so I could round that to $6,700.48. So that is my compound interest amount for a $5,000 investment at 10% semi-annually. It's going to be $67.48. That's how much my 5,000 will become. So this is my, what we call my future value. This is what we might call our present value. The 5,000 will become 6,700 in 3 years at that interest rate. And if I want to figure out how much did I actually pay in interest or earn in interest, I would simply take the 6,748 cents and I would minus the 5,000 from it. And basically it comes out to just under $1,700 of interest that I earned. So that's working it out with the formula. So we're going to do the problem here, and I'm going to clear my screen and we're going to do this problem. All right, business 20 students. I went ahead and wrote the formula in here. I cleared everything else off the sheet so we could work out this bottom problem right here with Fern Rob motorcycles, and what we're going to use the compound interest formula to solve this problem. And so it's a motorcycle company invested $250,000 at 4.5% interest, compounded monthly. And it's going to be for 3.5 years. I know my computer made that 312 years, but it's 3.5 years. And the first thing we need to figure out is how many times are they going to compound it annually, right? Well, if they're going to do it monthly, that means they're going to compound it 12 times a year. And so what I would need to do is just simply multiply how long is the loan for, and how many times you're going to compound it each time. So 12 times a year would be 3 times 12, which is 36. And then 0.5 times 12 is 6. So if you multiplied 3.5 by 12, you come out to 42 months. Simple enough. Here, we're going to have to divide the interest rate by 12. So 4.5 divided by 12 comes out to 0.0375, or 3/4, the same thing. So it's 0.75% every single time they compound it. Remember, the interest rate stated 4.5% is annually. So you have to, since they're going to compound it 12 times, you have to break that up into 12 different times in which they compound. So each time they compound will be 0.75%, or 0.0375. So what we're trying to find again is the compound amount. That's what A stands for. And so we're going to take our 250,000. We're going to multiply that by 1 divided by 0.375 to the 42nd power. And if we do the math on that first part, it would basically be 250,000 by 1.375. Sorry, it'll be 0.00375. That's be the division at 42 power. And if I do the math on that, so this is, I'm going to rewrite it. It's 1.00375 to 42 power. So I'm going to multiply these two together. 250 by 1.00375. So I'll check that in. Hold on a second, I can't see it. Okay, that comes out to 292.558. Sorry, 0.996. So 292,558 and 996. And if I was just to round that to the nearest dollar, it would just be $292,559. So my $250,000 investment for 3.5 years at 4.5% interest, my maturity value of that was $292,000. So I made almost 40. I actually did make $42,559 on that investment. That's how much interest I earned on that investment. Or if it was a debt, that's how much I would owe. So in this case, they were trying to build some manufacturing facilities. So they had $250,000 now. If they invested it for 3.5 years at 4.5% interest, they'd have an additional $42,559 to build their facility. So hopefully that helps. I recommend that you don't use the formula, that you just use the tables, and all of the problems in our exams and all the problems on the check-in assignment and quizzes are all based off of the tables. So you shouldn't have to use the formula, but if you want to, there's a little bit about that. All right, I'm going to move into present value. That'll be a separate video.